Good morning. Bruce Wile from IBM. I'm going to talk about a year in the growth of CAPI. Is that? All right. What I'm going to go through here is a quick look back at where we were a year ago at OpenPOWER, and then talk about what we've seen in the growth of the accelerators. Some of the charts won't be as exciting because we are working off of a PDF, but you'll certainly get all the ideas here. So a year ago, we had two accelerators that were being shown here on the floor. We had AlgoLogic's L3 order book, which was and still is the fastest financial order book from a latency standpoint. And we had the IBM Data Engine for NoSQL. And I was given a message to go forth and get more accelerators. At that point, we also had one developer kit card from Nalitech, and they're, of course, in the booth right over there. Now, you fast forward to a year later, we've got dozens of accelerators now. Over 20 of them we just put up on our website. If you go to ibm.biz/powercapi, you will see the listing of many of the accelerators that I'm going to just show their names here. We now have 3 developer kits, one from Nalitech, Alpha Data, and Semptium, all of which those cards and those companies are here today. Now, as we started to get more and more of these accelerators, we found that they were grouped into 3 categories. The first one we call transparent accelerators, and that's this green box here, where the accelerator and the library come together, and they give you an ability that you may have already had, such as compression or eraser code. These are things that you can do today, but you can do it much faster with an accelerator. And all you have to do is relink your library to point to the accelerator rather than where it was done in software. So that's the first class of transparent. The next class is a whole set of accelerators, and this is where we have the majority of our accelerators, whole set where it gives the application writer, the solution provider, a capability that they never had before. And therefore, you have to write new code with your accelerator in order to take advantage of the FPGA and CAPI. So that's the integration required set of accelerators. And finally, the third set is full solutions. This is where you receive the hardware, the PowerA platform. You get the FPGA, the card, the bit file that comes with it, all the middleware, all the application code, and it comes with a bow around it, support, and everything else into your office to provide a solution. So those are the 3 categories that we've seen all of these new accelerators fall into. So let's take a look at what these new accelerators are. In these 3 categories, we have a set of transparent accelerators, eraser code, just announced in China for the Hadoop market, which will be fully compatible with the Hadoop 3.0.0 coming out. We have an IBM will have a gzip compression CAPI accelerator available in July. And we have a few others that you can get and go look at on our IBM website. Integration required, of course, the IBM Data Engine for NoSQL is an integration required accelerator because Redis had to write to our new block API, our ARC API library, in order to start to use the CAPI flash. And now we have MongoDB and others starting to use it. And here's a list of many, many others, including a whole set of visual object recognition, facial recognition, emotion detection, which I'll show, available from SiliconScapes, who's over at the Alpha Data booth right there. Kevin's waving to us there. And they have some very compelling, cool CAPI demos of video analytics. Then we have our full solutions, things like genomics processing from Edico. And Edico's, you can buy genomic processing systems on the PowerA platform from them today. DRC and their graph analytics. You can see DRC and talk to them at the Xilinx booth right around the corner. And they have some fuzzy text searching and petascale analytics. We have another half dozen in the queue that are ready to come forward in the next few months. So keep checking back at that site for new listings. Questions on these? We're good so far? So without, the products also need the ecosystem around them. And as I mentioned, we have Alpha Data, Semption, and Nalitech all have developer kit cards. But we also have a bunch of frameworks and examples and tools for people to use to help you develop a CAPI accelerator. We have a DMA mover, which will be open sourced. We have all the approvals now to have it open sourced, and will be out in GitHub shortly. And all of these can be found, again, on that ibm.biz/powercapi website. The CAPI framework is an open framework created by a set of people out of Europe. We have a cafe to CAPI translation that came out of our Beijing lab. Thank you. And the PSL simulation engine, of course, has been there, and our memcopy example code. These are all out there to help drive the ecosystem and be a set of tools that you can use right out of the gate. So where is CAPI going? This is the old way of doing data analytics, where you have a whole lot of data, you pull it into memory, you do your analytics on it in memory. But if you want to bring in acceleration, at that point, without CAPI, of course, you have to bring in a device driver, and you add all kinds of latency and overhead, and there's no sharing of memory. So this would be FPGA acceleration without CAPI. CAPI makes all of this easier by extending the memory over here, making the calls back and forth much simpler. But this is where it's going, and this is where CAPI and analytics is all going to take off. Now you can see this with data analytics, where the data gets processed on the fly as it moves into the system, doing either pre-processing or a whole bunch of heavy lifting along the way. But it's not just for analytics. Video encoding and decoding, compression, eraser code, all of these other transforms are going to start to happen as we call data in motion, or bump on a wire. And you're going to start seeing these FPGAs do all this work, ingressing, doing needle in a haystack kind of checking, rather than putting all of that work onto the processor or having to go in and out of the system back and forth. So this is the direction that we're clearly seeing. And come next year, I'm sure we're going to have a ton of items to show here at the OpenPOWER booth that follow this model. Questions again on that? Okay. So just a pair of examples. The first one is dynamic time warping, which is a historical pattern matching. This came out of Tsinghua University. Professor Fu, I believe, is that right? Professor Fu is the dynamic time warp guy, where you have a stream of data coming in, and you give it a pattern to match, and using CAPI in the acceleration engine, it's picking out all of the patterns that might be like this. So if you're looking at data coming off of a bunch of power generators, and you know there's a failing signature, you can start to look for that signature before the failure starts to happen. That's one of many uses of this kind of pattern matching. And of course, the performance on this goes way through the roof because you're doing this through the accelerator. And then finally, again, no animation here, but this is always a fun one to show. Our friend Matt here, there is when the animation is going, he cycles through happy, sad, disgusted, and angry, and the text here changes with his face. So what do you do with something like that? Retail analytics. So if you can watch somebody's face as they pick up a product and look at it, you can get immediate feedback as to the packaging or what it is around that product that they like. And again, over at SiliconScapes with the Alpha Data, they have they have demos of all this going on. But beyond that, they're picking up the gender, the age, And in this case, because it's been trained, it says that this is Matt Yang. Or this is Matt, and it's not the other people here that it's been trained on. So there's some facial recognition capability in here. And this just shows all of the kinds of CAPI IP that they've put on the FPGA: facial detection, gender classification, age classification, et cetera, all working today and running on the Power 8 system. So those are just two examples of CAPI and how far that we have come with it. So questions? All right. Thank you.